Okay, still speaking with regards to angles. But wanting to describe an angle again in terms of radians and degrees. We've done this already before, so I'm not going to take much time at all. But just a reminder that a radian is the number of times you can lay the radii of any circle. I'm sorry, 1 radian is the size of the angle that you can lie a radius around the circumference of a circle. So let's say that this radius is equivalent to this arc. That angle is called 1 radian. It is about 57 degrees. I always get it backwards. It's either 57 or 53 degrees. So you can lay a circle's radius around its circumference. Halfway around is 3.14 times, but then all the way around the circle, remember you can lay the radius around 6.28 times. So 6.28 time radiuses can be laid around 360 degrees in a circle. And so the conversion factor that I use, remember conversion factor is like there's 12 inches in 1 foot, or 3 feet is equal to 1 yard. Those are conversion factors. Those are equivalents. Well, pi radians is 180 degrees. So if I ask you to convert 137.4 degrees to radian measure, you have to multiply by the fraction pi and 180, but because this has a degree symbol in it, you have to put the 180 degrees down below because there are pi, or 3.14 radii in 180 degrees. So 137 degrees, if we go strike, here's 90 degrees, 137 is about right here. So I'm expecting this to be about 2-ish, 2 point something radii. So if you take 137.4 times pi divided by 180, we get about too funny. I mentioned 2.4, and we get pretty much 2.4 radians is the size of 137 degrees. And I need you to be able to go backwards again. So let's go ahead and you should practice this one, but you're just going to multiply by pi over 180. Now remember, 57-ish or so degrees is 1 radian, so 26 is less than 1. So when you do that multiplication, you're going to get 0.459. To go in the other direction, 2.36 radians. Now wait a minute, we just did one that turned out to be about 2.4 radians. It was 2.4 was 137 degrees. So 2.36 radians is going to be a little bit less than 137 degrees. I'm going to flip that conversion factor. I want to convert this to degrees. And there are pi radians in 180 degrees, so my factor label method allows me to cancel those. And when you do this multiplication, you get 135. I'm afraid I don't have written down in my notes to the hundredths place, so I should go one more place. I'm going to let you do that. Likewise, the same thing for the next one. I'm going to go ahead and move on now to one last thing with regards to angles, and that is to converting angles from a decimal value to degrees, minutes, and seconds, and then vice versa. So first of all, architects, people in manufacturing, mechanical, might sometimes represent an angle as, I'm just making this number up, 136 degrees, which is in the second quadrant, because counterclockwise it goes about to right there, maybe 136 degrees. But you might have some number of minutes and some number of seconds. And these are the symbols we use. We're used to using them for the feet symbol and the inches symbol. But when it comes to an angle, we're talking about minutes and seconds. And there are 60 minutes in 1 degree, just like in the time in a clock. So what I'm going to do first is take 154.36 degrees, and I want to convert that to the nearest minute. Well, the 154 degrees stands. That's that's the full number of degrees. But I've got 36% of 60 minutes because it's 0.36. It's not a whole degree, it's 0.36 of. So I've got to take the 0.36 and multiply it by 60. And when you do that, we're going to get, sorry, I haven't turned the page. I'm afraid I don't have that. 0.36 times 60 is 21.6. So it says to the nearest minute, so I'm going to round the 21.6 up to 22 minutes. And I've given that in terms of degrees and minutes. Same thing with this one, you should do it. So it's going to be 715 degrees, but you need to take the 0.8 and multiply it by 60, which should give you 48, because it's 0.8 of a degree and there's 60 minutes in a degree. So I have 715 degrees, 48 minutes. If I want to go in the other direction, I just have to divide to get this into terms of decimal format. So 32 degrees is close to half of 60. So, I'm sorry, minutes. 32 minutes is just over half, close to half of 60. And remember, there's 60 minutes in a degree. So all you have to do is take 32 and divide it by 60. Up here you were multiplying by 60. 32 divided by 60 is 0.53, repeating. So we have 327.53 degrees, and we now have this in decimal form. Same thing here, just 47 divided by 60, and you get 0.783, so it's a negative 3.783 degrees, and we've expressed it in decimal form. Finally, if it's in degrees, minutes, and seconds, you just carry that process along. There's 60 seconds in any 1 minute, so 45 divided by 60 is 0.75. You put that with the 30, because it's 30 minutes and this number of seconds towards the next minute. Now you take the 30.75, so I'm just going to put here that this right here is equal to 0.75. Now you take the 30.75 and divide it by 60. Well, that's really close to a half, because 30 divided by 60 would be 0.5. So that's 0.5125, and you've got 211 degrees, 211.5125 degrees. I'm going to close that, so we just summarized converting from radians to degrees and degrees to radians, and then we